All right. Hey there, guys. Hey, happy Tuesday to you. Hopefully you guys are getting a chance to get out there and enjoy the weather. It was really nice yesterday. I know I got outside quite a bit yesterday. Um, didn't get a sunburn though. It's important to protect your skin. Wear long sleeves if you need to. Get a little sunblock on there. Get a hat. Don't get sunburned. I got sunburned the other day. It wasn't that fun. Um, but yeah, get out there and enjoy yourself, guys. It's good for you. Hey, couple things that I wanted to go over today. First off, as a review of some of the things that I showed you way back on like Friday, I think it was. This little picture right here, you can go find this in it's in the McSparron's notes section. So you guys have access to this right here, McSparron's notes. You can see my notes from every single day. I put this in here. It's obviously right here in the video. I also put in the link. It's mathopenref.com/pictorial index. Now, when you go to MathOpenRef, if you were to click on tangent, it would take you to a definition of tangent. If you were to click on secant, it would take you to a definition of secant. I'm just going to tell you right now, I'm going to give you a hint. That is really important for the PFA. That is really important for the PFA. That is really important for the PFA. Okay. For objective two. For objective three, we're going to get into like sectors and segments and stuff like that. But for right now, those are the three really important things. Make sure that you know the differences between those. Okay. I also want to show you a couple of other things here. So there are, in the PFA, there are 3 or 4 problems that deal with this new, okay? This is called Thales theorem. Okay, now I could try and explain Thales theorem to you, but Math OpenRef actually does a really good job. So I'm just going to open that up and you guys can take a look. Okay, so what Thales theorem says, the diameter of a circle always subtends a right angle. Okay, so see how QP is a diameter, all right? And as long as QP is a diameter, right? So you can take any diameter of the entire circle. And then if you make an angle where the ends of the angle hit the diameter like that, so basically it makes a triangle where one side is a diameter. It doesn't matter where I put point R. Do you see that? As long as that point is on the circle, it always makes a right angle, a 90 degree. I can flip it over here. It's always going to make a 90-degree angle. So there's going to be a number of these things. And if it tells you that there's a diameter in the PFA question, that's a big hint that it's going to be one of these 90-degree angle questions. Okay. So Thales theorem, let's see if I can write it out in simple language. Okay. Um, uh, if you make an angle where the ends make a diameter, then the angle is always 90 degrees. Okay, so let's take a look at this question over here. In the diagram below, PR is a diameter. So if that is a diameter, that means that any angle that is made by with the ends of that diameter has to be 90. So watch. That angle right there, look at that. The ends hit the diameter just perfectly, which means that that has to be a 90-degree angle. Also, I have another angle where the ends hit perfectly at the diameter, so it also has to be 90. Now, the cool thing here, by the way, guys, is that if I had made like that angle, it would have been 90. If I had made that angle, it would have been 90. It doesn't matter. They're all 90. Now, for the sake of our question, I see that I could have PQR. Remember that the middle, the vertex of the angle always goes in the middle. So that could also be RQP. Or I could have, I should have made those green. PSR or RSP, because those would go like that, right? P. Now I look down here and really, so that's got P in the middle, so that can't be it. That's got R in the middle, so that can't be it. That's got P in the middle, so that can't be it. Oh, not here. PQR. That one right there. Okay. Like I said, there's another couple. I'm going to put one of the other questions like this in your homework for tonight, but there's also going to be a couple that could show up in the PFA. Okay, this tricky one. Oh, guys, this one makes me so mad. They're trying to trick you. Okay. How many common tangent lines can you draw for the two circles above? Okay, so remember, a tangent, here, wait, looks like this. Okay, where the line skims along the edge, right? So I'm looking for what line skims right along the edge of the circle. Now, for these two, it's saying, can you draw a line that skims both circles? I'm going to show you which one, okay? So I can draw a line like this, ready? That barely skims both the circles. That's one. I can draw a line like this that barely skims both the circles. That's two. Most people that get this wrong in the PFA, they choose two. But there's another one. There's a line right there that barely skims both circles if the circles only touch at one point. And that's three. So there's going to be a question like this in your homework also. Yes, that's right. I put two questions in your homework. Deal with it. They're both multiple choice. They're pretty easy. If you have questions, obviously, you can email me and Mr. Hayden. We love getting emails from you guys, or you guys can schedule a time to do a one-on-one Zoom meeting. We love that too. Okay, so have a great Tuesday. Good luck with all this stuff, and let us know if you need help.